We are going to study the various strange stars today, white dwarf and neutron stars. One of the very famous example of the white dwarf is Sirius. But famous Sirius is not a white dwarf, the bright star in the night sky. Maybe you can easily find the Sirius, but that Sirius is not a white dwarf. Bright Sirius, we call the Sirius A, has a companion stars, Sirius B. This Sirius B is a white dwarf. Actually, we cannot look at the Sirius B by our naked eye. Sirius B was discovered by Clark in 1862. Mass of the Sirius B is similar to the solar mass. Actually, it's 98% of the solar mass. Diameter of the Sirius is about 12,000 kilometers. This is very similar to the diameters of the Earth. And the Sirius B has a really high temperature. Surface temperature of the Sirius B is 25,000 degrees. Surface temperature of the Sun is 5,800 kelvins. So this is much higher temperatures. So if you consider the stars as the mass of the M and the radius R, then to find the density, you have to mass divided by the volume. Then mass is the M, and the volume is given by 4 pi over 3 R cube. This is the volume. Then you can substitute solar mass 2.0 times 10 to 30 kilogram divided by 4 pi over 3, 6,400 kilometers cube. Then you can find the density of a white dwarf. It becomes 1.8 times 10 to 3 kilogram per cubic centimeters. So this mass, if you consider the mass of the ice cube, this is ice cube, is 1 centimeter. 1 centimeter, 1 centimeter. Mass of this ice cube, it's nearly equal to the 2,000 ton. This is very similar to the mass of the standard car. So you can find that it's really high densities white dwarf has. Then we could consider the neutron stars. Neutron star has a much higher densities. The mass and the radius of the neutron stars. Mass of the neutron star is similar to the solar mass. Very similar to the mass of the suns. And the radius of a neutron stars is about 10 kilometers. So size of a city. Then we could calculate the average density of a neutron stars. Can be calculated 2 times 10 to 30 kilogram. This is the mass of the suns divided by 4 pi over 3 times 10 kilometers cube. Then you can easily calculate this 4.8 times 10 to 11 kilogram per cubic centimeters. So compared with the density of the white dwarf, density of the neutron star is much higher densities. Then now we'd like to consider the mass density of the nucleus. What's a nucleus, by the way? Nucleus. If we consider the atoms, atom has a number of the electrons. And at the centers, actually it's made of the protons and the neutrons. So we call that this is nucleus. So we'd like to discover the density of the nucleus. Density of the nucleus can be calculated. Mass of the proton divided by the volume of proton. So it becomes 1.7 times 10 to minus 27 kilogram. This is the mass of the protons divided by the 4 pi over 3. About the size of the nucleus is 10 to minus 15 meter, femtometers. Then it becomes 4.1 times 10 to 11 kilogram per cubic centimeter. Density of a neutron star is nearly the same with the density of the nucleus. It can be said that neutron star is composed with nuclei without any space in between. Okay, this is the end of the practice.